Hello students, this is Shachi Tandon from Crack Chemistry with the class 10th topic. The name of the topic is Carbon and its Compounds Part 2. You can check the Part 1 of this chapter in the I button. Students, before starting, I just want to remind you to subscribe my channel for getting information about further important uploads. Press the like button if you like this video and share this video with your friends. So now let's see what we'll study today. So after introduction, we will study about organic compounds, organic chemistry, then what are the reasons for the formation of large number of organic compounds, or what is the reason for versatile nature of carbon. Then we will study catenation, Tetravalency of Carbon, tendency to form multiple bonds, and isomerism. After this, we will study a very important trick to write structures of different organic compounds correctly. That will be very helpful for you. Then in the last, we will study about the type of structural isomers. So first of all, we will see carbon and its compounds and versatile nature of carbon. So we will start our discussion with organic chemistry. So children, organic chemistry is the study of carbon compounds except carbides, oxides of carbon, carbonates and hydrogen carbonates. Then we will see what are hydrocarbons. So children, hydrocarbons are those simplest organic compounds which are made up of carbon and hydrogen only. Then what are other organic compounds? Other organic compounds are derived from hydrocarbons by replacing their one or more hydrogen atoms by other atoms or group of atoms. So I'm going to take methane as an example. Children, methane is the simplest hydrocarbon. Its formula is CH4. So we can obtain other hydrocarbon from this simplest hydrocarbon by replacing its hydrogen one by one with some other atoms or group of atoms. So in my case, I am going to replace hydrogen of methane by chlorine atom. So I am going to start by removing one hydrogen atom. So suppose if I have removed one hydrogen atom from methane, it will be left with 3 hydrogens only. So I have removed one hydrogen atom and it is substituted by chlorine atom. So you got CH3Cl. So this CH3Cl is called as chloromethane. So we got another organic compound from methane by replacing its one hydrogen with chlorine atom. So we got chloromethane. In the common language, chloromethane is called as methyl chloride. All these compounds you will study in very detail in this chapter only. Now children, I am going to replace one more hydrogen from here. So if you are replacing one more hydrogen, you will be left with 2 hydrogens only, CH2, and in place of 2 hydrogens, 2 chlorine will come, so CH2Cl2. It is called as dichloromethane. Now children, I am going to replace one more hydrogen. So if you are replacing one more hydrogen, you will be left with 1 hydrogen only. So you will get CH with 3 chlorine, CaCl3. So this is called as trichloromethane, and this trichloromethane is very popularly known by its common name, chloroform. Last case, when the only hydrogen atom is replaced by chlorine atom, what is left here? We will get CCl4. CCl4 is called as carbon tetrachloride, or its name is also called as tetrachloromethane. So this is tetrachloromethane. So I hope this is clear to you. Now we can define organic chemistry as the chemistry of hydrocarbons and their derivatives. So what is organic chemistry? It's the chemistry of hydrocarbons and their derivatives. So students, we know a large number of organic compounds at present. And out of these large number of organic compounds, some are naturally occurring, but some are synthesized in lab. Initially, it was assumed that these compounds can be extracted only from the natural substances, and it was thought that these compounds can be formed only within a living system. Means they cannot be synthesized in the laboratory. That was the initial opinion. And it was assumed that a vital force was necessary for their synthesis. But Friedrich Wöhler disproved this in 1828 by preparing the first organic compound, urea, from ammonium cyanate. So I am going to show this reaction here. Children, ammonium cyanate has the formula NH4CNO. So this is the formula of ammonium cyanate. He changed this. He converted this ammonium cyanate into urea. Urea's formula is NH2CONH2. So if you look carefully, you will find that ammonia and urea both have the same number of atoms. Only difference is in the arrangement of atoms. So in urea, rearrangement of atoms has taken place. So NH4CNO is ammonium cyanate. I am writing its name below ammonium cyanate. This is ammonium cyanate. And this is urea. So urea was the first organic compound which was synthesized in the laboratory. Now we will study something about the carbon. Children, we see many things around us, and most of the things which we use in our daily life are made up of carbon. For example, the food we eat, the clothes we wear, the books we read, the notebooks in which we write, many more things, they are made up of carbon only. In fact, we ourselves are made up of carbon compounds only. So, and one more point, the number of carbon compounds is estimated to be in millions. And one very interesting pattern I want to share with you. If we keep all the compounds formed by all the elements together at one place, and the compounds formed by carbon at one place, we will find that the compounds of carbon will be more in number than the compounds formed by all the other elements put together. So you can see such a large number of compounds carbon can form. So it's a very, very interesting thing. So now we will see. You might be thinking, what is the reason why this property is shown by carbon only and not by some other element? So after the end of this session, we will conclude that we will come to know that the nature of covalent bond enables carbon to form large number of compounds. So we are going to study this in detail. Reasons for large number of organic compounds, or what is the reason for versatile nature of carbon. So students, two factors are noticed in case of carbon. These two factors are, first one is the catenation. So what is catenation? Catenation is the property of self-linking of carbon atoms. Carbon atom, they undergo self-linking. How they undergo self-linking? Through covalent bonds. So the property of self-linking of carbon atoms through covalent bonds to form long chains. When carbon atoms are linking together through covalent bonds, they form long chains. And these long chains may be straight chains, or they may be branch chains and rings of different sizes. So this property is called as catenation. This is a very important property which is called as catenation. And one more point I would like to mention here, this property of catenation is next found in sulfur. But in comparison to carbon, it is to a much lesser extent. Now, I will give some example in support of the point which I have mentioned just now. We have seen that different carbon atoms undergo self-linking through covalent bond and resulting in the formation of long chain, which may be in the form of a straight chain or branch chain. So first I am taking the example of the straight chain. So children, I have taken 4 carbon atoms which have undergone self-linkage through covalent bond. And one more point I would like to mention here, that while writing these structures, children, make sure that your carbon must be tetravalent. So how you can check it is tetravalent? Just count the number of bonds which is it is forming. So here you can see the first carbon atom. I'm writing number 1 here. I'm writing this is the one carbon atom. This is attached to 1, 2, 3, 4 other atoms. 1 carbon and 3 hydrogen atoms. So it is tetravalent. Now the second carbon atom. It is attached to 1 carbon this side, 1 carbon this side. So now 2 more hydrogens must be here to make it tetravalent. Similarly, this carbon atom will be attached to 2 other hydrogen atoms. And this carbon atom will be attached to 3 other hydrogen atoms. So we can see here the self-linking in the form of a straight chain. So I am writing here this is the straight chain. Now, how the self-linking can take place? What is the other way? The self-linking can take place in the form of the chain also, branch chain. So I am writing one more structure here. This time I'll use a different color so that it will be clear to you. So I'm writing here this is C. This is C. I'm writing here C. One more C here, one more C here. So 3 carbon atoms, but the 2 carbon atoms are present on the second carbon atom in the form of branch. So now you have the concept of tetravalency. This you have to keep in your mind. This carbon will be attached to 3 other hydrogen atoms. This carbon also will be attached to 3 other hydrogen atoms. This carbon will also be attached to 3 other hydrogen atoms. And this carbon atom will also be attached to 3 other hydrogen atoms. So you can see that this is the branch structure, branch chain. So I am just writing here this is the branch chain. So you can see that catenation can take place in the form of a straight chain or in the form of branch chain. Now in the form of rings also, rings of different sizes. So I want to show you here rings of different sizes. So I'm just taking one example. I'm taking a ring of 3 carbon atoms. So I have taken 3 carbon atoms here. Again, this carbon will be attached to 2 more hydrogen atoms to make it tetravalent. Similarly, all the carbon atoms will be attached to 2 more hydrogen atoms to make it tetravalent. So this is a ring of 3 carbon atoms. Similarly, I can form one more ring here of 4 carbon atoms. So I'm just writing here with this yellow colored pen only. This C here, this carbon, each carbon is attached to 2 hydrogen atom. 2 hydrogen here, 2 hydrogen atom here to make it tetravalent. Similarly, this carbon also will be attached to 2 hydrogen atoms. This carbon will also be attached to 2 other hydrogen atoms. So this is the ring. So this is the first reason why carbon forms such a large number of compounds. We have seen catenation. Catenation is the self-linkage of carbon atom through covalent bonds, and this catenation can take place in the form of a straight chain or branch chain or the rings of different sizes. So here we have seen 2 rings here, 2 rings of different sizes. Now the next point which I am going to discuss is the tetravalency of carbon. So children, carbon atom is tetravalent. That is, its valency is 4. This point I was discussing with you in the previous slide also. So I am just writing here the carbon atom. Valency of carbon atom is 4. So carbon atom is tetravalent means its valency is 4. So I have written here this, I am showing the carbon here. So if its valency is 4, so carbon is capable of bonding with 4 other atoms of carbon. So it can form a bond with 4 different atoms of carbon, or it can form bond with some other monovalent elements. As I have shown in the previous slide, 4 hydrogen atoms can be attached here, or 4 other monovalent atoms can be attached here. So second point is the tetravalency of carbon. At a time it can form 4 bonds with 4 carbon atoms or with other monovalent elements. Now one very important point is that due to its small size, the size of carbon atom is small. So if the size of the carbon atom is small, it can easily and strongly hold the shared pair of electrons. So what will happen? Because of its small size of carbon, the bond which carbon forms with other elements such as hydrogen, oxygen, sulphur, chlorine. So nucleus of carbon can hold the electron pair of the bond with hydrogen, oxygen, sulfur, chlorine very strongly. So hence it makes the compounds of carbon exceptionally stable. So when the compounds of carbon are exceptionally stable, it increases the number of carbon compound, because the third point I would like to discuss here, tendency to form multiple bonds. Children, due to tetravalency we have discussed, small size we have discussed, carbon forms stable multiple bonds. The multiple bonds can be double bonds, can be triple bonds with other atoms like carbon atoms. With oxygen atom it also forms, and the nitrogen atoms. So it forms stable multiple bond which can be double or triple bond S. So I am going to show you these bonds here. So first I'll take the example of this compound. You can see here I am showing here the carbon. This is the structure. There's a single bond between this carbon and carbon. So how many hydrogens will come here? The first carbon atom will have 3 hydrogen atoms to complete its tetravalency. The second carbon atom will have only 1 hydrogen atom. And the last carbon atom will have 2 hydrogen atoms. So what is this? This structure is called as complete representation. So I am writing here, this is complete representation. Then the same structure can be represented in the form of condensed representation. So in the condensed representation, these 3 hydrogen atoms will be written together. So I am writing here C, then all the 3 hydrogen atoms together, CH3, then this carbon with 1 hydrogen, so CH3CH, then a double bond, and the carbon with 2 hydrogen atoms. So this representation is called as condensed representation. This representation is called as condensed representation. Then, I hope this is clear to you. So here you can see that carbon forms a stable double bond with carbon atom. Now I would like to show you some more examples. So second example I am taking here the carbon, you can see it forms a triple bond. So CH3, single bond C, triple bond N. So here there is a triple bond present between carbon and nitrogen. So this is the condensed representation, and if you want to write the complete representation, you can write like this, CH3. So I am showing all the 3 hydrogen atoms here. All the 3 hydrogen atoms here. Then a carbon, between carbon and nitrogen you have a triple bond. So you can see this is the complete representation. And the first one was the condensed representation. First one is condensed representation. This is condensed representation. Now one more example I would like to share with you. This is third example. So I am writing here CH3, the condensed representation I am writing this time, CH3 C H double bond O. These compounds are there in your syllabus. You will study all these compounds in detail. So this is the condensed representation I am writing here. This is the condensed representation. Why I am writing again and again? So that you will be able to learn here only. Students, now I will discuss the fourth reason for versatile nature of carbon. The fourth reason is isomerism. So isomerism is the property in which 2 or more compounds have the same molecular formula but have different properties. So this property is called as isomerism, and the compounds which show this property are called as isomers. So now we will study type of structural isomers. So first we will study chain isomers. So what are chain isomers? Chain isomers are the compounds which have the same molecular formula but different arrangement of carbon chains. The carbon chains can be present in the form of a straight chain or in the form of branch chains. So now we will discuss some examples. So first example I'll take of butane. So I'm just writing here isomers of butane. Isomers of butane. So students, one very simple and easy trick I want to tell you for writing isomers of any hydrocarbon, because this question is frequently asked. So for writing isomers of any hydrocarbon, what you will do, first you will write the straight chain isomer. Means all the carbon atoms you will write in the form of a straight chain. So I am going to write all the carbon atoms in the form of a straight chain. So as butane is having 4 carbon atoms, its molecular formula is C4H10. So first I will write the straight chain isomer. So 4 carbon atoms, C, H3 will be the first one. Then the second one is CH3, CH2, CH2, CH3. So this is the first isomer of butane. This is also called as N-butane. N stands for normal butane here, or simply it is called as butane. So whenever you have been asked to write isomers of any alkane, what you will do? First you start your answer with the straight chain isomer. After that, reduce the chain by 1. Here you can see that we have a chain of 4 carbon atoms. Now for writing the next isomer, take a chain of 3 carbon atoms. So what will happen? One of the CH2 group, it will be written as a branch. So this CH2 group, it will be written in the next isomer in the form of branch, and you will have a chain of 3 carbon atoms. So now I am going to write the second isomer. So first isomer we have written, that was N-butane. The second isomer, what we will do? We will take a chain of 3 carbon atoms. So CH3, then we will have CH, then CH3, and what about the CH2, which was present in the form of a straight chain in the previous isomer? That will be present here in the form of a branch. So now you can see here we got the second isomer. And what is the name of second isomer? Children, don't worry about the names, because I'll upload a separate video for naming the alkanes, alkenes and all other hydrocarbons. So here I want to tell you simply how to write the name of any hydrocarbon. What we will do, we will see the chain. So our chain consists of only 3 carbon atoms. So 3 carbon atoms, we use the word propane, 3 carbon atoms and alkane. So anyways, I am going to discuss this nomenclature in detail in my next video. And you can see that the second carbon atom has CH3. The CH3 group is called as methyl group. So what will be the name of this compound? First we will write the number of that carbon atom on which branch is present. So on the second carbon atom, branch is present. So I have written 2 here. Then we will write the name of the branch. So I'll write here 2-methyl, because CH3 group is the methyl group. Then we will write how many carbon atoms are present in our chain. So you can see that our chain consists of 3 carbon atoms. So 3 stands for propane. So I have written the name 2-methyl propane. Children, this name is the IUPAC name. IUPAC is also called as IUPAC name. Now, this compound is very popularly known by the common name also. So in common name it is called as isobutane. So children, always remember one thing: in common system, whenever a methyl group is present on the second last carbon atom, it is called as iso. For writing the common name, the whole of the carbon atoms of the compound you have to count. So iso, and 4 carbon atoms total are present, so it will be named as isobutane. So isobutane is the common name. So now you can see that for butane only 2 isomers are possible, because if you try even, you cannot write any more isomer. And always remember one point, that as the number of carbon atoms in hydrocarbons increases, number of possible isomers also increases. Now one more additional information I want to give you here. LPG cylinders, they mainly contain butane and propane, and they also contain a small amount of ethane. Now I want to discuss another example. I'll take pentane. So I'm going to write isomers of pentane here. So as I told you, the simple trick, isomers of pentane. So if you follow this trick, then writing different isomers will become very easy for you. So what is the simple trick which I told you? You will always start from the straight chain. So we will write the straight chain isomer of pentane. So pentane is again an alkane which consists of 5 carbon atoms. So what is the formula of molecular formula of pentane? This is C5H12. This we will discuss in detail in my in my next videos. So C5H12. So I'm going to write 5 carbon atoms in a chain. So first CH3, CH2, then CH2, one more CH2, you can count also. So we have 4 carbon atoms till now, and the terminal carbon atom will have CH3. So the name of this compound will be, either the common system it is called as N-pentane. N-pentane, N stands for normal pentane, or simply it is called as pentane. So this is the first isomer we have written. Now how to write the second isomer? I already told you that for writing the remaining isomers, you have to reduce the chain by 1. And the reduced number of carbon atoms must be present in the form of a branch. So I'm going to write the next isomer. I'll take a chain of 4 carbon atoms here. So if I'm taking the chain of 4 carbon atoms, CH3, so CH2 I have to write in the form of CH to satisfy valency. So CH3, CH. Then again I'm writing here CH2, CH3, and the fifth one will be written in the form of a branch. So you have to take a special care of valency, for which I am going to discuss in my next videos also. So this is the second isomer of pentane. You can see here, if I start numbering the carbon atoms, I'll number from this side, left to right, because our aim will be to give least number to the carbon which possess the branch. So 1, 2, 3 and 4. If I number from left to right, the carbon atom which possess the branch, this is branch, gets the number 2. And if I number from right to left, what will happen? The carbon which possess the branch will get the number 3. So it is getting more number here. So this is not the correct way of numbering. We will number from left to right. Then what I will do? First I'll write the number on which branch is present. So you can see on the second carbon atom branch is present. So I'll write number 2, then put a dash. After that write the name of the branch. So name of the branch is methyl. So I have written here 2-methyl. Then you just see the chain. Your chain consists of 4 carbon atoms. So for 4 carbon atoms we use butane. So 2-methyl butane. So students, after 2, after a number we will put a dash. Then methyl M will be capital, and there is no gap between methyl and butane. So this is the IUPAC name. This is the IUPAC name. I hope it is clear to you. Now I'll discuss the common name with you also. So as I told you in the common name, if a methyl group is present on the second last carbon atom, this is called as iso. And for writing the common name, you have to count all the carbon atoms, because in IUPAC name, we count the carbon atom only of a straight chain. But for common name, we will write all the carbon atoms. So we will write the word iso here. Iso. Total 5 carbon atoms are there. So it will be isopentane. This is the common name. So now in case of pentane, you can see that one more possibility is there, because in butane you saw that only 2 possible isomers were there. Here, if you look carefully, you will find that there's one more scope. You can reduce the chain to 3. So if we reduce the chain to 3, then there will be 2 branches present on the second carbon atom only. So I'm going to write the third possible isomer. I will take a chain of 3 carbon atoms. So CH3, then second carbon atom, as there will be 2 branches, so no hydrogen will be there on the second carbon atom. So this is the fourth carbon atom, CH3, this is CH3. So this is the fourth, this is the another third isomer. Here you can see it is having the same molecular formula but different structure. So if we say it's IUPAC name, children, you can easily see that I'll use a different color so it will become easy for you to understand. A chain of 3. So for a chain of 3 means for 3 carbon atoms we use the word prop. And the second carbon atom has methyl group, but 2 methyl groups are there, so we will use 2, comma 2, 2 for the second methyl group. So 2, comma 2, then put a dash here. Then as 2 methyl groups are there, we will write dimethyl, 2,2-dimethyl. For 3 carbon atoms, we will use the word propane, 2,2-dimethyl propane. So this is the IUPAC name, children. Now what about common name? So students, always remember for writing the common name, if there are 2 methyl groups present on the second last carbon atom, we use the word neo. So neo, and total 5 carbon atoms means pentane you have to write. So neopentane. So this is the common name. So this point you have to remember that when 1 methyl group is present on the second last carbon atom, we use iso. When 2 methyl groups are present on the second last carbon atom, we use the word neo. So common name is neopentane. So now you can see that there is no more 4th isomer is possible. So always remember, as the number of carbon atoms increases, the number of possible isomers also increases. As butane had only 2 isomers, but in case of pentane you saw it had 3 isomers. So now we can say that the isomerism exhibited by compounds having the same molecular formula but different properties is due to difference in arrangement in its carbon chain. So this type of isomerism is called as chain isomerism, or we can say that when the isomerism is exhibited by the compounds have same molecular formula but different properties. Why the properties are different? Due to the difference in its carbon chain, then this isomerism is called as chain isomerism. There are many more types of isomerism which you will study in your higher classes. So here you have studied chain isomerism. So children, I hope this point is clear to you. So now we will see what we have discussed today. We have studied about organic chemistry. After introduction, we have studied what are organic compounds. Then we have studied reason for large number of organic compounds or versatile nature of carbon. Then we studied about catenation, tetravalency of carbon, tendency to form multiple bonds, and isomerism. Then very important thing is that I told you a trick to write the structures of different organic compounds correctly and confidently. Then types of structural isomers we have studied. So students, thank you so much for watching this video. In the last, I just want to remind you to subscribe my channel for getting information about very important uploads which I am going to upload soon. And please like this video and share this video with your friends. Thank you so much. Have a nice day.